Hi Algebra 2B students, how are you today? Today we're working on section 8.6a and b. We are working with radical expressions and rational exponents. So let's take a look here. The first thing I want to point out to you is you know what a radical sign looks like, right? When we have a radical sign that is by itself, we'll call it, with a number underneath it, you know that that means to take the square root, right? If we have a radical with a small index out front, this is called like a 3, you know this is the cube root, and this is the 4th root, right? And so these are radical expressions because they have the radical sign in each of them. What we can do is rewrite radical expressions with as a rational exponent. Again, rational meaning fraction, okay? So for instance, the square root of 4 is really to the first power, and we really are taking the second root. And so this radical expression can be written with a base of 4, a power of 1, and a root of 2. The cube root of 8, notice that is 8 to the first power, can be written as 8 to the 1/3 power over root. The 4th root of 16 can be written as 16 to the 1/4. Notice it's easy to remember that the power goes on top because people in power are at the top. Notice it's easy to remember that the root goes at the bottom because roots are at the bottom like plants. So all we're going to be doing on this first page is switching radical expressions to rational expressions and rational exponents to radicals, and we're going to be solving some problems. So let's go ahead and do that. Notice on the first problem, it has 27 to the 4/3. They wrote that as a radical expression, and that's what the instructions say. Write each expression in radical form and simplify. Always take the root first, it is easier. You are welcome to do this on the calculator also, but you'll see that I don't. So let's take a look. We are taking the cube root of 27 in parentheses here. That is a 3 to the 4th power, and that is an 81. Notice why we always take the root first, the cube root, instead of doing the power first, is 27 to the 4th power is a really, really large number. And then for me to try to take the cube root of it would be difficult. However, if I take the root first, the cube root of 27, pretty easy for me, that's 3. 3 cubed is 27. And then raising 3 to the 4th power, that is much easier, okay? And let's just show you too, let's refresh your memory. So let's take a look and see how we did with our answer. 27 raised to the 4/3 power. Let's see if we got the right answer. We did, 81. How do you put a cube root in the calculator? You hit your math button, and if you notice, number 4 is cube root. You hit number 4, and let's try the cube root of 27. We were correct, that's a 3. What if you want a root other than 3? Like let's say you want the 4th root. What you would do, first hit the root that you want, 4. Okay, then hit your math button and go one more down to 5. Notice you now have a 4th root. Let's do the 4th root of 625. Notice that's a 5. Okay, so you can always use rational exponents on your calculator, or now you know how to use radical forms. Let's do the next problem. 49 to the 3/2. The power is 3, the root is 2. So that's 49. There we go. Now, because the root is 2, that's a square root. We don't usually put the 2 out there, but it's okay to show it. Again, 49 cubed is really hard for me, so I'm first going to do the square root of 49, which is 7 cubed, and I'm feeling lazy today. Let's put 7 cubed in the calculator. 343. Here we go, 16 to the 3/4. That is a root of 4. Here's another way. There's lots of ways to write the power in the root. This time I put the power on the outside. So let's do the root first. The 4th root of 16 is 2. 2 cubed is 8. Okay, next, write each expression by using rational exponents. So all we're going to do is we have radicals. We're going to show the power and the root, and we are going to write it with an exponent that is a fraction. So take a look here. We have 4, power of 2, root of 5. 4 to the 2/5. Power on top, root on the bottom. Isn't that nice and easy? They didn't even ask us to simplify. Notice on number 11, we only see a 19. We're going to have to add the power and the root ourselves. Right, that 19 really is to the first power. The radical sign without an index in front indicates a square root. This is 19 to the 1/2. Power over root. Base is 6. Power of 5, root of 4. Now notice down here for the next problems, they actually want us to do some work. It says simplify each expression. Let's see if we can actually do some math, some simplifying on the inside of this fraction. Notice 24 divided by 3, I can do, right? That's an 8. So that is 8 over x cubed to the 1/3. Okay, now you can split up when you have a power and a root or an exponent for numerator and denominator. We can do those separately. That is 8 to the 1/3 divided by x cubed to the 1/3. There we go. We know the cube root of 8 is 2. And you know that when you have a base and you have one exponent raised to another, that you multiply the exponents. So this is x, and 3 times 1/3 is 1. There's our final answer. Let's take a look here. Notice that I can't put both of these expressions under one radical sign, because this is a square root and this is a cube root. They would have to match. So I'm just going to go ahead and do any simplifying I can separately. Let's see. The square root of 49 is 7. The cube root of 8 is 2. And now, you know, I'm not sure here. X to the 6 power with a cube root of 3. Let's write it. X power of 6 root of 3. Oh, look at that. Our math is super easy. We now have 7 times 2 is 14. X. And the exponent is 6 divided by 3 is 2. So isn't that nice when you write a radical form in rational and then you can see the math in the exponent. Let's take a look here. The square root of 17 over 13. I don't really want to split this up into square root of 117 over square root of 13 because neither of those come out evenly, come out perfectly. So that's okay. We have math to do under here. What is 117 divided by 13? Right? We always do. That radical sign works as parentheses, so we should do some work there first. That's a nice 9. This is the square root of 9, and that's a 3. Let's go to our next page. They want us to simplify each expression. Okay? So what we're going to do is let's remember, if we do have roots that are the same, we can put them under one root, like they did here. Also, if they are together, we can separate them, either way that it helps us. We will also use rational exponents to help us reduce exponents. So here we go. The cube root of x to the 8th times the cube root of x to the 4th. We wrote that under one radical is the cube root of 8 to the x times 8 to the 4th, x to the 4th. That is the cube root of x to the 12th. Right, when bases are the same and they're being multiplied, you add the exponents. And I'm going to write this rationally. That's x with a power of 12 and a root of 3. That is x, and 12 divided by 3 is 4. Notice before in the original problem, I cannot take the cube root of 8 perfectly or the cube root of x to the 4th perfectly. that's okay. By putting it together, we were able to. Let's move on to the cube root of 125x to the 6th. The cube root of 125 is 5, and let's write our rational exponent on the x. That is x power 6 root of 3. That is 5x squared, and we are done. Isn't that nice? Let's take a look. In this expression, notice that we first have the radical sign works as parentheses. We have some work we can do. This is the 5th root. 64 divided by 2 is 32, x to the 10th. And we can do the 5th root of the numerator and denominator separately. The 5th root of 32 is 2. And we have x, the power is 10, the root is 5. 10 divided by 5 is an exponent of 2. Next problem, notice I can't take the cube root of 2x or the cube root of 4x squared perfectly, but we know that we can combine them and multiply them under one cube root. 2 times 4 is 8. X times x squared is x cubed. The cube root of 8 is 2. X to the 3rd power, and you're taking the 3rd root. Power divided by root, 3 divided by 3 is 1. That is x to the 1st power. Last one, the 4th root of 625. We already checked on the calculator, that's a 5. Let's take a look here, let's write this out. X is to the 8th power, we're taking the 4th root. 8 divided by 4 is an exponent of 2. There we go. Notice these all worked out perfectly. What happens when they don't work out perfectly? That would be 8.6b. So, how do you simplify radical expressions that do not have perfect roots? What we're going to do, we're first going to factor the expression into perfect roots and non-perfect roots. Okay? We do this with fractions. Notice that if we have 11/8, 11/8 isn't perfect, but an 8 does go into 11 perfectly once, and we have 3/8 left, right? So we are going to do the same with radicals. Okay, so factor the expression into perfect roots and non-perfect roots. Simplify the perfect roots and write the expression first, followed by the non-perfect roots. Just like fractions, we put the perfect whole out front, followed by the part. Just like our money, we put the perfect whole dollars first, followed by our fraction of the dollar. So here's some examples to simplify. And on your paper, on the back, there's a squares and cube chart to help you. So let's take a look. Notice the square root of 50 is not perfect, okay? So we are going to find factors of 50 where we might have a perfect square root. So notice, I do know that 50 is 5 times 10, but notice I cannot take the square root of those perfectly, so I'm not going to use those factors. I'm looking for one factor of 50 where the square root is perfect. That would be 25 times 2. Okay, so what I'm going to do, I'm going to go left to right and write my expression with perfect squares and what's ever not perfect left over. So here's my 50. I'm going to write that as 25 times 2. I can take the square root here. Here I cannot. Take a look at x to the 6th. Notice if you put your 2 out front that this is already perfect. X to the 6th power divided by the 2nd root. 6 divided by 2 is 3. So I am just going to write x to the 6th. Notice y to the 7th, the square root of that is not perfect. Power divided by root, 7 divided by 2 is not perfect. So what I do is, well, I have y to the 7th. I do have y to the 6th in here, y to the 5th, y to the 4th, right? And so what I start doing is counting down from my exponent of 7 until I do have a perfect square root. So let's see, y to the 7th, let's go down one, y to the 6th, sure. Y to the 6th, I can take the square root of that perfectly. 6 divided by 2 is 3. How many y's am I missing? 1. So, notice the expression underneath the square root radical sign is still what I have above, but I divided it into perfect roots and not perfect roots. Now let's go left to right and do all the simplifying we can. Okay, the square root of 25 is 5. That goes out front. It's not under the radical sign because we actually took the square root. The square root of 2, I cannot do underneath the square root. The square root of x to the 6 is x cubed, right? 6 divided by 2 is an exponent of 3. Y to the 6, 6 divided by 2, exponent of 3. There we go. The square root of y I cannot do. Here is our simplified expression, our whole and our part. Let's go over to B. The cube root of 40 is not perfect, but is there a factor of 40 that is a perfect cube? Yes, 8 times 5. X to the 5th, 5 divided by 3 is an exponent, is not perfect. 4 divided by 3 is not. 3 divided by 3 is x cubed. How many x's am I missing? I need 2 more to have x to the 5th. Y to the 6, 6 divided by 3 as an exponent is perfect. Okay, let's go left to right. Let's find our perfect cubes and take the cube root, and anything we cannot do will stay under the cube root radical sign. The cube root of 8 is 2. The cube root of 5, I cannot do. The cube root of x cubed, 3 divided by 3, is an exponent of 1. The cube root of x squared, 2 divided by 3, I cannot do. Stays under the cube root in the trash can, as Mrs. Adams says. Y to the 6, 6 divided by 3 is a perfect exponent of 2. There we go. Final answer. Let's take a look here. 4th root of x to the 7th, 4th root of x to the 6th. Neither one is perfect. They both have the same 4th root. Let's at least put them under one 4th root symbol and see what we can do. X to the 7th times x to the 6th is x to the 13th. There we go. Notice 13 divided by 4 is not a perfect exponent. Let's go down. How about 12 divided by 4? It sure is. Let's write x to the 13th as x to the 12th times x. Notice it's still x to the 13th, but the 4th root of x to the 12th I can do. That is x cubed. 12 divided by 4 is 3, followed by the 4th root of x I cannot do, and we bring that along. Last one. The cube root of negative 54 z to the 17th. What do we do with that negative? Well, we just pull it out. That's really a negative 1. There we go. Now, we need, the cube root of 54 isn't perfect. Are there any factors of 54 that are perfect cubes? It is 27 times 2. Z to the 17th, 17 divided by 3 isn't perfect. Let's count down. 16 divided by 3 is not perfect. 15 divided by 3 is. I'm going to write that as z to the 15th. I am missing 2 z's. Notice my expression I wrote is the same as above, but I split it up into perfect cubes. Let's go ahead and run it through. Let's do all the perfect math we can. The cube root of negative 1 is negative 1. The cube root of 27 is 3. The cube root of 2 is not perfect. The cube root of x to the 15th, 15 divided by 3 is 5. Oh, that's a z. Z to the 5th. Sorry about that. There we go. The cube root of z squared is not perfect. And there's our final answer. Let me rewrite it so it looks a little better. There we go. Have a fantastic day.